Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 1st, 2025, which was about 2 days ago. The standout contribution is a rigorous, large-scale benchmark that shows several modern optimizers, like ADMA Mix, MARS, and DMUON, can reliably match or beat ADAM-W for large language model pre-training when tuned carefully across model size, batch size, and training horizon. The paper is titled Benchmarking Optimizers for Large Language Model Pre-Training, and the implications for model training are quite significant. The study standardizes protocols, tunes hyperparameters deeply, and releases code so practitioners can pick the right optimizer with confidence. On X, researchers highlight a broad, controlled benchmark, comparing optimizers across model size, batch size, and training duration, praising robust experiments and practical guidance. Engagement looks solid, with around 170 and 65 likes. The previous segment highlighted the broad benchmark and its practical guidance. Figure 2 now shows training dynamics on a 520 million parameter mixture of experts model, comparing DMUON, SOAP, and AD-EMA mix. The curves track validation loss versus tokens, so lower is better. The dashed blue baselines mark ADAM-W trained to 42,000 and 336,000 steps, which frames whether the newer methods beat standard practice. The three methods closely track each other early, then converge near or slightly below the long ADAM-W baseline by the end. So the previous figure focused on a mixture of experts run. Figure 1 ranks optimizers on a 720 million parameter llama-style model with a 1 million token batch. The plots show final validation loss versus training tokens, so lower curves indicate better outcomes. AD-EMA Mix and MARS lead across durations, which signals strong large batch efficiency, while several methods sit above the ADAM-W baseline. The separation widens at shorter budgets, then narrows slightly as training extends toward 48 billion tokens. Alright, the previous figure compared large batch rankings on a bigger model. Figure 3 shows validation loss curves for a 124 million parameter model, with panel A using a small batch and panel B using a much larger batch, so the total tokens stay matched. Many optimizers beat ADAM-W in short runs, but AD-EMA Mix finishes best as tokens grow, which signals strong stability. Signum, Lion, MARS, and Prodigy improve notably in the large batch panel, while Sophia struggles or diverges beyond the chinchilla horizon. So the previous figure covered batch effects at small scale. Figure 4 compares MUON against DMUON across 3 model sizes, plotting final validation loss versus tokens, and lower is better. The solid DMUON curves sit below the dashed MUON curves in all panels, which shows that applying decoupled weight decay to all parameter groups consistently helps. The gap is largest at shorter budgets and remains visible as training extends. Wrapping up, 2 takeaways stand out. First, with careful tuning, AD-EMA Mix, MARS, and DMUON often beat or match ADAM-W across scales and large batches. Second, practical knobs matter, like deeper warm-up, stronger end decay, and correct decoupled weight decay. The broader implication is smarter, workload-specific optimizer choices. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.